Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll talk about integration by part. We use integration by part when there is no relationship between the variable inside my integral. The formula of integration by part is integral of u dv is equal u times v minus integral of v du. Usually I don't demonstrate formulas, but because this one takes less than 1 minute and it's very easy to demonstrate, I will do it for you. I know that the derivative of u times v is equal to derivative of u times v plus u times the derivative of v. And if I want to maintain the integrity of the equality, whatever I use on the left-hand side of my equality, if I use the same thing on the right-hand side of my equality, the integrity of the equality is maintained. So if I do integral on the left-hand side and integral on the right-hand side, my equality remain true. I know that me here, I want this integral of u dv, which is here. So if I bring this to that side, I would have the integral of u dv. So I will put integral of derivative of u times v minus integral of v du. I can write v du or u dv because 2 times 3 is equal to 3 times 2. Does not matter. Equal to integral of u times dv. Yeah. But I know the integral is the antiderivative. So the antiderivative is before the derivative. So before the derivative of the derivative of uv is uv. So the antiderivative of this is uv. So it becomes u times v minus derivative of v du is equal to the integral of u dv. And this is my u dv that is here is my u dv that is here. And uv is this, and v du is that. This is how they came up with this formula. Anyway, now that you know, let's start with exercises. Let's start with the first exercise, which is integral between 1 and square root of e of ln of x dx. And I always, when I have to write ln, I always have to put whatever ln of whatever number it is in absolute value, because ln of negative value does not exist. If you put on your calculator ln of minus whatever, you will have an error. Anyway, there is no formula for ln of x. And if I want to do it in the traditional way, it's going to be very complicated. So now let's try to do it with integration by part. I say let u equal ln of x. Then du equal 1 over x dx, because the derivative of ln of x is 1 over x. And then if I take my dv, because in my formula I have u dv and I have du and I have dv here. So I would need u and du and dv. And my dv is equal my dx. The antiderivative of dv is v and the antiderivative of dx is x. So my v is equal to x. And now let's apply the formula. I will write it here. Integral of u dv is equal u times v minus integral of v du. So my u here is ln of x. So ln of x, and my v here is x times x minus integral of v, which is x, and my du is 1 over x dx between 1 and square root of e. This part, I don't have to do anything with it because it's outside my integral. So I will copy it, and again 2 times 3 is equal to 3 times 2, so I can write ln of x. I like it better this way, minus, and I know x divided by x, I can simplify it, minus integral of 1 dx. And there is a formula in my previous video, I showed it to you. You can apply it. The formula of 1 dx is x plus between 1 and square root of e. And I don't have to put plus e because my integral has boundaries. So it becomes x ln of x minus x between 1 and square root of e. And now all what I have to do is I will replace x by square root of e, my upper bound, minus I will replace another time x by 1, my lower bound, and I would have my answer. So this is equal, if I want to replace x by square root of e, it becomes square root of e ln of square root of e, and here I don't have to put the absolute value because square root is always positive, minus square root of e. You know what? Let's write it on a new line. It's better. So it's equal square root of e ln of square root of e minus square root of e minus, and I open my parentheses, 1 ln of 1 minus 1. And here I can write ln of square root of e as ln of e to the power 1/2 because I can replace square root by power 1/2. So it becomes square root of e ln of e to the power 1/2 minus square root of e minus, and I know that ln of 1 is equal to 0. If you put it on your calculator, ln of 1, you will see it's equal to 0. There is two things that I need you to know by heart. Ln of e is equal to 1 and ln of 1 is equal to 0. So minus ln of 1 is 0 times 1 is 0, and minus times minus is equal to plus 1. I don't want you to think this is equal. I will take it out. And now I will apply here the law of logarithm. If I have ln of e to the power 1/2, I will bring the 1/2 here. You studied it in previous year. So square root of e times 1/2 ln of e minus square root of e. Actually, I have, it is minus 1 inside the parentheses. It will become plus 1 outside the parentheses. So if I get rid of the parentheses, it becomes plus 1. Now I know ln of e is equal to 1, and 1 times 1/2 is 1/2. So I can write square root of e divided by 2 minus square root of e plus 1. Now, square root of e divided by 2 minus square root of e, it becomes minus square root of e divided by 2 plus 1, and that would be my final answer. Now let's do another exercise. The second exercise will be integral of x squared ex dx. And again, I don't have any relationship between x squared and ex. I cannot go from x squared to ex or from ex to x squared. So I will do integration by part, and I will say let u equal x squared, then du is equal to 2x dx, and I will take dv is equal to ex dx, then v is equal to ex, because the derivative of ex is ex. And I will apply my formula, integral of u times v equal uv minus v du. So while practicing, if you keep on writing the formula, you won't have to study it. You will know it by heart. So my u is x squared and my dv is ex dx, which is here the ex dx, and this is my u. So I have integral of u times v. So integral of x squared ex equal, and here I will have the formula u, and my u here is x squared, and then I have v, and my v here ex times ex minus integral of v, which is ex, and my du is 2x dx. 2x dx. And again here, I cannot go from e to the power of x to the 2x. So I will do uv again. So this will be equal x square e to the power of x minus, and then I will take the second time, I will take u equal to, I will take here u equal to 2x, then du equal to dx, and I will take my v is equal ex dx, my dv is equal ex dx, so my v is equal to e to the power of x. And then I will apply it here, minus, and I open my bracket, u times v is 2x times e to the power of x minus integral of v du e to the power of x, and my du is 2 dx times 2 dx. Let's bring this up a little bit. Here I forgot to bring the v is equal ex, du is equal to let's write it again. Here, if I take my u is equal to x, u is equal to x, so my du is equal x dx, and my dv is equal ex dx, so my v is equal to ex. So it's u times v, which is 2x multiplied by ex, minus v, which is ex times du, which is my du is here, if my u is 2x, my du is 2 dx, not x dx. I wrote it right the first time. When I copied it wrong. It's 2 dx. So minus integral of v du, my v is equal to ex, and my du is equal to dx. Now, my 2 is a constant. I can take it outside. My integral is equal x square ex minus 2x ex minus 2 integral of ex dx. But I know the integral of ex dx, because the derivative of ex is ex, will be ex plus c. So this is equal x square ex minus 2x ex minus times minus is equal to plus 2, and integral of ex is e to the power x plus c. And I look here, I have ex all in the on my three terms. I can factor out my ex, so is equal e to the power f x square minus 2x plus 2 and plus c, and that would be my final answer. Let's do another exercise. The other exercise would be integral of ex sine x dx, and again I don't have a relationship between ex and sine x, so I will do integration by part, and my formula is integral of u dv is equal uv minus v du, and here I take my u is equal ex, so my du is equal ex dx, and I will take my dv is equal sine x dx, so my v is equal minus cosine x, because the derivative of cosine is minus sine. If I want plus sign, I have to put the v is equal to minus cosine x. So I will apply the formula here. So I will recopy ex sine x dx is equal u times v is equal minus ex cosine x minus, because here my v is a minus here, integral of v du minus cosine x, and my du is ex dx. Okay? Here minus times minus is plus. I can take it out outside my outside my integral, the minus. So ex sine x dx is equal minus e to the power x cosine x plus integral of cosine x, and I will put ex here because 2 times 3 is equal to 3 times 2. I can play with the position. Now again I will look, there is no relationship between ex and cosine x, so I will do integration by part again. So I will take here u equal to ex, so du equal ex dx, and cosine x dx equal my dv is equal to cosine x dx. So my v would be equal sine x. V equals sine x, because the derivative of sine x is cosine x dx. And again, I will replace this by uv minus integral of v du. So I will recopy, and you will understand why I am recopying when I finish. Sine x dx, why I'm writing this all the time, is equal minus e to the power of x cosine x plus u, my u is ex here, and my v is sine x, uv, minus integral of v du, I will put duv, ex, and sine x dx. So this is v du. My v is sine x and my du is ex dx. And if I look here, integral of ex sine x dx, and here I have integral of sine x dx. So if I bring this to that side, it will be, the minus will become plus. So integral of ex sine x dx plus integral of ex sine x dx, it becomes 2 times integral of ex sine x dx is equal, I will write this first, ex sine x minus cos ex cosine x. It's the same thing. I can write minus ex cosine x plus ex sine x. It will be the same thing. And now I realize that I have here ex in common, so I can factor it out. So 2 ex sine x dx is equal ex sine x minus cosine x. But me, I don't want 2 ex sine x, because the question was integrate ex sine x dx. So if I divide here by 2 and I divide here by 2, I maintain the integrity of my equality. So 2 divided by 2 would disappear. So integral of ex sine x dx is equal to ex divided by 2 sine x minus cosine x. And then I will stop this video here. The next video, it will be about integration of trigonometric function. But don't worry, I will do a lot of videos about everything. So if you like my video, please subscribe to my channel. That would help me to continue doing video for you. Thank you.